So today we're going to be learning how to solve two-step equations. Yay!
Yay! Yeah.
So I know what most of you all may be used to is learning simple algebraic expressions that only involve one mathematical operation, whether it be subtraction, addition, multiplication, etc. However, today we're going to take it one step further and we're going to be learning how to solve two-step equations. So this example, we're first going to do an example as a little warm-up to get you familiarized by what you have learned from in the past. And so here we have x minus 10 equals to 4. So essentially we're going to be focusing on the side with the x, and we're going to see what types of changes are being made to this x. So we're going to undo this x. We see that there's a minus 10 conducting on the x. So to undo it or isolate the x by itself, we're going to have to do the opposite of subtraction, and we're going to have to add 10. And from the rule of equivalence, we see that what we do to one side of the equal sign, we have to do to the opposite side. So we're going to have to add 10 on the opposite side, plus this gives you 0. You get x by itself equals to 4 plus 10, so that's 14. So translating this idea over the two-step equations, it's very similar in idea in that we're going to be undoing and isolating the x. However, with two-step equations, you're not going to be only using one mathematical operation. Instead, in this case, you're going to be using two. In the most common cases, you're going to be using either addition or subtraction first, and then we're going to be using multiplication or division to get rid of the coefficient in front of the x. So to isolate this x, we're going to have to we first see that we have to choose between either addition or subtraction. So here we have a 3x plus 10. To get rid of the plus 10, we're going to have to do the opposite of addition, which is subtraction here. So we're going to have to subtract 10, and once again, on the opposite side of the equal sign, we're going to have to also subtract 10. This gives you, here 0 again, so 3x equals to 9. Now we see that there's a coefficient in front of the x, which is 3. And we see that it's 3 multiplied by x. However, to undo this and isolate the x by itself and get our ultimate answer, we're going to have to do the opposite of multiplication, so we have to divide both sides by 3. This will end up giving you x is equal to 3. So that's our answer, and a way to check this answer is to plug the x value you get back into the original equation to see if both values on the two sides of the equal sign are indeed equal. So to plug this 3 back in, we're going to be doing 3 times 3 plus 10, and we're going to be seeing if that is indeed equal to 19. 3 times 3 is 9, plus 10. 9 plus 10 is 19, so we see that 3 is actually the answer. Understood?
Yes. Wait, but teacher, why can't we divide the 3 first?
So if you divide the 3 first, you have to divide every element in the equation by 3. So you're going to get 3x divided by 3 plus 10 thirds equals to 19 thirds. However, you don't want to do this because then you'll have a lot of fractions and dirty decimals that you do not want to have involved in your equation because it leaves a lot of room for mistakes. So that's why we're going to mainly stick to using just integers. So now we're going to do a little chant. If you guys can repeat after me to help you kind of remember the material that we just learned today.
Okay.
Two-step equations.
Two-step equations.
Just what you expect.
Just what you expect.
You gotta start by
You gotta start by
isolating x.
isolating x.
First you gotta subtract or add.
Subtract or add.
That's step 1.
That's step 1.
Not so bad.
Not so bad.
Now you gotta have x on one side.
have x on one side.
There's one more step.
There's one more step.
Multiply or divide.
Multiply or divide.
Two-step equations.
Two-step equations.
Simple as that.
Simple as that.
Isolate the x.
Isolate the x.
And that's a fact.
And that's a fact.